So this is your set A question. So number one, the idea that many of the features of the landscape were to be explained by rapidly occurring events. It is a principle that is given by what? So passing also uniformitarianism. So uniformitarianism, it is a very slow process. Uh, we see in geology there is a concept called law of uniformitarianism, where we see the present processes and we assume about the past processes. And uniformitarian processes are very slow. That's also called as a gradualism. But catastrophism, it is a theory where the earth has largely been shaped by sudden or short-lived and violent events. That means these are rapid events. You can take the example of volcano, earthquake, those all are catastrophic events. So that's the answer will be catastrophism. Then also, second question, the inclusion in meteorites considered to be droplets that have condensed from the original solar nebula. So those droplets in meteorites what we call chondrules, which is found in chondrites. So these are your rounded grain that found in chondrites, what we call chondrules, which form from the molten or partially molten droplets in space before being created to the parent asteroid. So those are small droplets. So the answer will be chondrules. Then comes what is the average albedo of the whole Earth? It's a data type question. So it will be 0.3. That is the average albedo of the whole Earth. Then comes to this is a very easy question. Bow huए lava. It is otherwise called as ropey lava. So ropey lava always produces smooth surface. So it will be smooth surface. Then A lava, it is called as a blocky lava. It is always from a rough surface, a blunt surface you can say. Then comes to mafic magma. So mafic magma that comes from the deeper source, so that it will produce a white eruption. And felsic magma, they are produced from a shallower level, so it is directly under the electrostatic pressure, so that it will produce a explosive eruption. So the answer will be B. So question number 5. In some cases, the sediments on the downgoing plate are added to the accretionary prism. When the partial thrust of the prism propagates into the downgoing sediments, and it will form a duplex structure, adding the sediment to the bottom of the accretionary prism. That's why the accretionary prism grow. So it is in case of your subduction plate, subduction region. So this is your subducted plate, and this is your overriding plate. So accretion meaning is a process of growth and you can say enlargement because of when this plate, that is subducted plate, it will subduct beneath this overriding plate, then material will scrape out from the subducted plate. So it means that metal will remove because of this motion or converging motion between overriding plate and subducted plate, and those material, they are added at the accretionary prism, or I can say at the base of the accretionary prism. That's how the accretionary prism grow. That process is called as a accretion. So accretion means also like that gradual buildup of sediments by, you can say, accretion. You can confuse it with abduction, but in abduction it is simple called as the opposite process of subduction, that is measure abduction. Normally it is formed in orogenic belt, so where some of the material from the subducting oceanic plate it will emplaced onto the continental plate, where you will find the ophulates. So it can emplaced onto the backhand basin. So this part can be a backhand basin where there might be extension or compression. There are two types of extension and compression of backhand basin. So because of this movement, some material from the oceanic crust it will emplaced over the, you can say, key continental plate. So because that is a process of called abduction, and the gradual scraping of material and it is added to this accretionary part, that is your accretion. So according to the question, the answer will be accretion. So widespread asymmetrical bulges along the continent edges of, that fall directly into the sea with steeper slope towards the coast. So it is your graded escarpment. So it is found in majorly in Africa. Then comes to glacial drift. So any sediments that produce by glacial movement, that is called as glacial drift. So you can so for that, all types of glacial transported sediments they can be called as glacial drift. So the answer will be D. Next comes to delta. So in the delta, the thick layer consists of coarser particles that drop soon after the entering the water body. In delta, there is a special type of delta called Gilbert type of delta. Gilbert type of delta, which has three layers: top set, bottom set, and foreset. So top set is the transition between river and ocean, you can say. So it will look like this. This is your top set, this is your foreset, this is your bottom set. So bottom set consists of finer sediments. Then as you go up, the particle size will increase, so that the top set bed it consists of coarser particle and it will suddenly fall into the sea. So here the answer will be your C, top set layer. Which one of the following is not correctly matched? So Mississippi River, you can see in this triangle, Mississippi is towards the river vertex, river corner, you can see it is a river dominated delta. Ganga Brahmaputra delta, it is a tide dominated delta. So you can say a estuarine delta. So that will be the incorrect one. And Nile also it is wave dominated. You can see here is Nile. Then Fly River delta it is also tide dominated. You can see here Fly. This is Fly, tide dominated. This is Nile, wave dominated. This is Mississippi river dominated. And Ganga Brahmaputra also it is tide dominated. So the answer will be for the Ganga Brahmaputra delta. It will be option B. It comes to a nearly horizontal or landward sloping bench developed due to deposition of sediment by ocean wave. So this will be your bar. So it is a nearly, you can say, horizontal deposits that divides the, you can say, foreshore and backshore. As a slope towards the, you can say, ocean, and also slope towards the landward. So that's why the answer will be bar. Kaolinite, you all know that it is a very common question. So when feldspar do chemical weathering, it will produce kaolinite. So the weathering product of feldspar will be kaolinite. So answer will be A. Let's consider the following statement regarding soil formation. So I think similar soil can develop from different parent materials. Soil are developed by the weathering, can say disintegration of rocks. It is not formed from a specific type of rock. It can form from different type of rock. So similar soil can develop from different parent materials. Then time is not an important component. Obviously, during soil formation, it is a very slow process. So time is very important in case of, you can say, formation of soil. And the climate is more important than other formation of soil, the other factors in formation of soil, because the climate basically it influences two factors, that is you see temperature and rainfall. So temperature, rainfall also related to weathering of rock. So if you have a high temperature, then rainfall will increase. So degree of weathering, that is chemical weathering, will increase, and high temperature also that will facilitate the chemical weathering as well as physical weathering. So, because climate is affecting the primary thing, that is the disintegration of rock, so it will be the important factor for formation of soil. So, option 1 and 3 will be correct. So, it will be answer B. Then comes to Poisson's ratio. The simple transverse strain by axial strain. This was given answer A in our answer sheet. Now it is corrected, that is transverse strain by axial strain. Then comes to the difference between the total stress and the mean stress of a geological system. The total stress, that is suppose sigma 1, sigma 2, sigma 1, sigma 2, sigma 3. So when you will take the mean stress, that is sigma 1 plus sigma 2 plus sigma 3 by 2. Sigma 1 minus this mean stress, it will be deviatory stress. And hydrostatic stress, when all the stress are equal, that is hydrostatic stress. Then differential stress is the difference between maximum and minimum stress. Sigma 1 minus sigma 3. So according to the question, the answer will be deviatory stress. We also consider the following geological section of a folded terrain and the corresponding statements. So here is a folded terrain where this G is you can say it is igneous. Then A is your Cambrian arkose, S is Cambrian shale, N is your Miocene, and N is your fine sand. So in between, see this is G and A, this is Archean granite, and it is Cambrian. So Archean ended at 2500 million years, and Cambrian start from 538 million years. So there is a age gap here, so we can define a uniformity. And also the upper part of these upper unit, they are also folded. Upper unit is also folded. That also indicate a uniformity. So now this upper part, this A part, it is a sedimentary rock, and the lower part it is a igneous rock. So the uniformity between the sedimentary and metamorphic part, it will be a non-conformity, or you can say heterolithic uniformity. So the rock sequence contain a disconformity, it will be incorrect, because you can say it is uniformity, but it is not a disconformity. Disconformity is a parallel uniformity. Then the rock sequence contain non-conformity. Obviously, it is a non-conformity by heterolithic conformity, where you will find deposition of sedimentary rock over igneous rock. Then conformity formed prior to the folding. So if you see the diagram, the sequence of event will be like this. First, there will be the granitic emplacement, then the deposition of sediments. First, this is the granitic emplacement, then deposition of sediment like this will be. This is a granitic emplacement, then there will be horizontal deposition like this, then they get folded by compression. So that means the folding, it is the uniformity, it is prior to the folding. So this option will be correct, and two options will be correct. Then granitic body got emplexed in the core of the anticlinal fold. As you can see, the uniformity is formed prior to the folding. That means the granitic body already emplaced before the folding. So that will be no such condition where granitic body will be emplaced in the core of the anticlinal fold, because it is, granite is older than the arkose. So option B, that is 2131. When it comes to LS tectonite, it is also very easy question. L tectonites we use for lineation, S tectonite we use for foliation, that is a planar. L tecton is linear, and if you combine them, that is LS tectonites, which is different, which is deformation in both linear and planar fabric elements. So the answer will be A. So in this question, there is also an uniformity you will find between sail and arkose, because this arkose is Cambrian, and sail is Miocene. So there is also an age gap here. So that means you will find a disconformity here in between your Cambrian arkose and sail. Okay, so this option will be correct. So it will be 1, 2, and 3. So it will be 1, 2, and 3. Then also consider the following diagram of fault and the corresponding statements. I think the hanging wall has moved off neither down. It is a strike slip fault. So the fault plane is vertical. So in case of vertical fault plane, there is no footwall hanging wall. So this option will be incorrect. The fault is a strike fault. So there is no reference here. There is no bedding plane here. So we cannot say whether it is a strike fault or other type of fault. Because strike fault is when the strike of the neighboring conductor or bedding plane, it is parallel to the strike of the fault plane. So there is no the strike of bedding plane is given here. The fault is a left-handed cyclic fault. It is a left-handed cyclic fault. It will be correct. And the slick side, if you form, it will be like this. It will be horizontal. So option 3 and 4. Then comes to the consider the following statement: an antithetic fault deep towards the master fault. So antithetic fault means it is a type of fault which is opposite to the master fault. An antithetic fault deeps in the same direction as the master fault. It will be wrong. Sorry. Antithetic fault deep towards the master fault. That means the master fault is dipping towards the master fault, means it is dipping opposite to the master fault. So it will be correct. And antithetic fault dips in the same direction as the master fault. So it will be wrong, because antithetic fault dips opposite to the master fault. Then synthetic fault, it is deep towards the master fault, it will be incorrect. But synthetic fault deep towards the same direction of the master fault, it will be correct. You can see here. The synthetic fault, if this is a master fault, then synthetic fault will dip towards the along with the master fault. An antithetic fault, they will dip towards the master fault or opposite to the master fault. the answer will be 1 and 4. When it comes to the angle of internal friction of a rock is 28 degree according to Coulomb fracture criterion. So what will be the acute angle between conjugate shear fracture plates? Really simple. You can say 90 minus internal friction angle. It is psi. It will be the acute angle between two conjugate shear fractures. It will be 90 minus 20 will be 62. The answer will be 62. We also consider the following statement regarding to homogeneous deformation. So, in case of the homogeneous deformation, only the straight line remains straight line, the parallel line remains parallel. And in the heterogeneous, they will change. So, this will be correct. Straight line remain straight line after deformation. Then your parallel line remain parallel after deformation. So, option 1 and 3, that is D. So the section of a myelinite on which asymmetrical shear strength indicator based observed and analyzed. See, in a lineation structure, so you can take a section parallel to the lineation. So here is a section is taken parallel to the lineation. If you take a section, suppose ki perpendicular to the lineation, then it will be destroyed. Similarly, in case of foliation, you have to take a section perpendicular to the foliation. So, if there is a foliation structure like this, you will have to take a perpendicular section to see the foliation or to see the changes or asymmetry within the foliation structure. So, in a myelinate foliation, you have to take perpendicular section, and in a lineation case, you will take the parallel. So the answer will be here. This will change to perpendicular to the myelinite foliation and parallel to the aggregate lineation. In a river valley, dipping beds show a straight line, straight linear outcrop across the river. So it is about your V's rule. So it is in a vertical bed, the outcrop will show a straight line. So the bed so vertical. It will produce also no V in case of vertical bed. So regarding the outcrop pattern of a reclined fold, which one is correct? So the fold axis strain nearly 45 to the axial trace will be incorrect because in case of reclined fold, the fold axis it should plunge in the direction of axial plane. So both the trend of the axial plane and the fold axis should be same. That is called as a reclined fold. So in this option, it is the say right angle to the fold the trace line. In this produce it is a I-shaped geometry. So which is a you can say in case of carbon hinge line, you will produce I-shaped geometry. So this option will be incorrect. So there is only one option left. The fold axis plunges towards the concave side of the fold outcrop. Suppose this is a reclined fold. If you take a horizontal section like this, it will produce an outcrop. Horizontal section like this. Okay. So it will produce a outcrop like this. Like this. So this will be the axial trace and also the trend of the you can say fold axis. So this will be the trend of the fold axis and it will be towards the concave side of the fold. So that's why in case of reclined fold, so this option will be more correct. The fold axis plunges towards the concave side of the fold axis. And in all other cases, we will say okay, during for outcrop, suppose in case of say vertical fold, right? So it will outcrop like this, and this will be the axial trace, and the fold axis it plunges perpendicular 90 degree to the axial trace. So this case is more like a vertical fold condition, and it will be appropriate for a reclined fold condition. So the answer will be B. When comes to a limestone bed strikes 30 degree and dips 70 degree towards southeast. So limestone bed strikes north 30 degree east. So it will be north 30 degree east. North 30 degree east. This will be its true dip direction. It will be south 60 degree east. Then what will be the expected dip on the bed if seen east-west load section? So it is asking you what will be the dip in this direction, east-west direction. So basically it is asking about the apparent dip. So you have to calculate the apparent dip along east-west direction. So theta it is given 70 degree. So we can calculate the beta from here. This is true dip direction. This is apparent dip direction. So this angle will be 30 degree. So this is 30, this is 60, and this is 30. So beta will be 30 degree. So you can put the formula tan alpha equal to tan theta into cos beta. So if you put the value, the answer will be 67 degree, approximately 67 degree towards east. As you see, there is no calculator given, so you can also solve it like the bed is dipping towards southeast. So that means in east-west road section, the dip towards southeast means towards east. So you'll never found the dip towards west. So as it is asking about east-west direction, but the true dip direction is towards southeast. So that means you will never found any dip in between them which should be greater than 70 degree, because 70 degree is the true dip. So if you see this section, this is your strike direction, this is true dip direction. Okay. So true dip direction is in this direction dip is 70 degree. Okay. So as you go from true dip direction towards the strike direction, the dip will decrease. Okay. But it will not decrease up to 8 degree in the east direction. It will decrease, but not to that negligible amount, because the 8 degree apparently will be very close to strike direction. So that means this option will be incorrect. Then comes to these two options, they are given. One is given 78 degree, so it is not possible the apparent dip will be greater than true dip. So this will be incorrect. And also they are incorrect because it is given the dip towards the west. The remaining one is this one. So this will be correct. Next, if in a crystal, the glide component is represented by A by 2 plus B by 2, then A by 2 plus C by 2, or B by 2 plus C by 2, or A by 2 plus B by 2 plus C by 2, then the glide plane is. So glide planes are, you can say, the combination operation, the translation plus a mirror plane. So we represent three types of glide. One is axial glide, which is either A by 2 or B by 2 or C by 2. Then diagonal glide, it is a combination of any two vectors, that is A by 2 or B by 2. that is A by 2 plus B by 2 or B by 2 plus A by 2. So the answer will be diagonal glide. Then in diamond glide, we take the components as A by 4, B by 4, C by 4. Summation of either A by 4 plus B by 4 or B by 4 plus C by 4. So for that, then it will be diamond glide. So when vector is A by 2 plus B by 2, it will be diagonal glide. If only A by 2 or B by 2, it will be either A glide or B glide, whatever you name, that is the axial glide. Then in diamond glide, it will be A by 4, B by 4 and C by 4. This will you will find this in a book called FD Bloss. FD Bloss. Then open form of crystal that composed of 3, 4, 6, 8 and 12 faces, and all of these are parallel to same axis. This is a very easy question, that is all know prism. In prism, all the faces must parallel to a axis. Then which one among the following pair is not correctly matched? Pyrope is Mg garnet, that is Mg3Al2, it is correct. Albandine Fe3Al2, it is correct. Spessartite, it is manganese bearing, it is correct. Then overweight, it is chromium bearing. So this is incorrect. That is Ca3 Cr2. So it is given Al2. So it is incorrect. C3Cr2 Si3O12. This is overweight. Then comes to the next question. The relative importance of crystal form is proportional to the point density or spacing of the respective lattice plane. It is called as a Bravais. So the rate of crystal growth in any lattice direction is proportional to the point density in that direction. So this is your law where the crystal plates develop along plane defined by the points in the lattice. So it will develop in that direction where maximum lattice point is there. So in other words, you can say all crystal face must intersect atoms and molecules that make up the points. So this is, you can say, these are the lattice. So in one direction, you can see all the lattice plane are connected to in a single line of plane, you can say. So that's why the development will be more in one direction. So then the rate of crystal growth in any lattice direction is proportional to the density, point density in that direction. That means the more the density in the direction, the more will be the growth in that direction. That is called as a Bravais law. So you can say the plane lattice shown in the figure. It will be more common if they develop along the lattice point level 1. If they develop along level 2 or less commonly they develop along level 3, 4, they will not connect all the lattice plane. So there will be no development in that direction. So the more the lattice point density or lattice points, so in that direction it will develop more. So that is called as a Bravais law. So phase is more commonly developed in a crystal if it intersects a large number of lattice points. So because of large number of points, it should be the growth should be proportional to the point density in that direction. And this is also correct. The relative importance of crystal form is proportional to the point density or spacing of the respective lattice plane. Because if there is less spacing in between lattice plane, in that direction growth will be more. So it will be Bravais law. Then spindle is the example of isomorphism. Okay, isostructural will say. Then comes to, this is the statement of polytypism. So polytypism, it is a variety of polymorphism, and when we call polytypism, when you have different sequence the structure. It is a stacking structure where different segments within a structure have same unit length in 2 dimensions, but commonly have different unit length in third dimension. So in one dimension, you'll have different unit length or different cell length. So this is called as polytopicity. So both statement will correct, and statement 2 is the correct explanation for statement 4. Then a temperature composition diagram of two components A B involving no solid solution. If you are saying involving no solid solution, that means either it will be a eutectic or it will be periodic. So there is no periodic option here. So you will take the eutectic. So at the eutectic point, you take AB. At the eutectic point, the A crystal, B crystal, and liquid all will coexist with each other because of that the degree of freedom is 0 here. According to question, so answer will be at eutectic point. Then again the structure of silicate type Si2O7. Si2O7 it is 2:7, which will be a sorrow silicate. That is the mechanism of solid solution if Pb2 plus substitute K plus in microcline. So Pb2 plus where it substitute K plus in microcline and it gives the green color to the microcline. So as it is a plagioclase, the substitution is often a coupled type of substitution. The answer will be coupled substitution. When it comes to monticelite is a calcium bearing end member, so it belongs to olivine group. You will see this is olivine group. First phyllite, then monticelite CnGSiO4, then cysteonite CaCSiO4, then larbonite C2SiO4. So it is belongs to olivine group. Also, which one of the following statement is not correct? Olivines of nearly equal FEMG constitute chromatide, so it will be wrong because chromatide is Mg rich olivine consists of Mg rich olivine. Chromatide is a rock which contain more percentage of magnesium. Then iron rich olivine occur in both alkaline and plutonic hydroxyl rock. It is not found in acidic plutonic rock, so it will be incorrect. Then magnesium rich olivine is distinguished from diopside by its poor cleavage. This is magnesium rich and poor cleavage, but large optic axial angle and high birefringence, it will be incorrect. Because olivine has a optic axial angle 80 to 90 and large optic axial angle and high birefringence. And diopside has 60. Generally is not correct. For olivine, nearly equal FEMG. So it has high magnesium content, but the olivine it is found in that contain equal amount of FeMg. The olivine content is equal. Then iron rich olivine, that means firelight. So firelight, it can occur with hypervessel rock, plutonic rock, uh, because the phosphorate it cannot occur with quartz, but firelight can occur with quartz. Then magnesium rich olivine distinguished from diopside, poor cleavage, large optic axial angle, and high birefringence. It doesn't have high birefringence. And the optic axial angle of olivine group minerals varies from 82 degree. Actually, the optic axial angle is from 82 degree up to you can say 86 degree. It is not 134 degree. and in comatite also will get more Mg percentage, that is more Mg bearing olivine. And iron rich olivine occur in both alkaline, acidic and hydrolysis. It will be also type of incorrect. You have to review this question again because fast is also incorrect. Because the 2V angle it is not 134. If you will take the obtuse angle, then it can be 134. But which angle it is saying whether it is acute angle or obtuse angle, it is not mentioned here. And magnesium rich olivine, it has here it has a large optic axial angle, but the birefringence of these two nearly same. So you have to review this question again. Okay. The next class we'll review this again. Then comes to which one of the following minerals does not belong to pyroxene group. So we take first opacite, it is a pyroxene. Then cosmochlorite is a chromium bearing pyroxene. Pigeonite obviously it is a pyroxene. So these are clinopyroxenes. Then eckermannite it is amphibole, sodium bearing amphibole. So the answer will be D. Which one of the following statement in relation to CO2 with silicate melts is correct? So first, the CO2 when it is added with the silicate melts, what will happen? CO2 has lower solubility in melts with low polymerization. So CO2 generally it polymerize melt. It helps to polymerize melt. So it always prefer melts that has low polymerization. So CO2 has a greater degree of solubility in low polymerized melt, that is in mafic melt. That's why CO2 will have higher solubility in melts with low polymerization, which is opposite in case of H2O. So H2O will has higher solubility in high polymerized rock or melt. So you can find it in the Winter book. The effect of carbon dioxide, water, and pressure in the binary phase diagram. The answer will be B. That means we can say that CO2 tends to increase the viscosity and H2O tends to decrease the viscosity because CO2 helps in polymerization, H2O helps in depolymerization. Then the best known synthetic analogy of mantle composition, it is pyrolite, pyroxene plus olivine. Then also ultramafic rock contain module value of olivine, orthopyroxene and clinopyroxene. So that is your ultramafic diagram. Olivine, orthopyroxene, clinopyroxene. So olivine, it is saying it is 50%, orthopyroxene 30 and clinopyroxene 12. So it will be within the triangle. So it will be lazolite. The olivine orthopyroxene, it is Haswargite. Then olivine clinopyroxene, it will be Behrlite. Then orthopyroxene clinopyroxene, it will be Westerite. So all three components in major constituents, it will be a lazolite. Then comes to stocks and batholiths are primarily distinguished on the basis of stocks and batholiths generally They are distinguished on the basis of their aerial extent. Strokes are smaller exposure, but with the larger exposure that is greater than 100 square kilometer. So the answer will be D, that is aerial extent. Then also the texture with which exsolution lamina of K feldspar that occurs in albite host. So albite host means albite is greater than K feldspar. In this case, in between albite and K feldspar, you know exsolution texture. So there are three types of exsolution texture. One is perfect, antiperfect, mesoperfect. When K feldspar is a host, it is perfect. When albite is a host, that is antiperfect. When both are same amount, then it is mesoperfect. So the answer will be antiperfect. When a porphyritic basalt contains phenocrystal glassy groundmass, which one of the following statement of petrogenesis of the basalt is correct? It contains phenocrystal plagioclase. Okay, phenocrystal plagioclase. So both plagioclase and groundmass crystallize in the deeper level. So if they all crystallize in the deeper level, they both should have coarser grain. So it is saying it is a glassy groundmass. So glassy groundmass means heat solidified at shallow depth or in the rapid cooling condition. So both plagioclase and groundmass formed during eruption of the basalt. If both are formed during eruption in basalt, then both should be fine grained. So it will be incorrect. Plagioclase crystallize at deeper level of the crust while the groundmass solidify at shallower level. It will be correct. Plagioclase is coarser grained and it is crystallizing at deeper level, and the groundmass it is finer grained, so it should crystallize at a shallower level. So option C will be correct, and option D, plagioclase crystallize at shallower depth. If it is shallower depth, then it should be coarser grained. Sorry, finer grained. So it will be incorrect. So option C. Then consider the phase diagram. Correct sequence of crystallization. So this is your A. It is an anorthic field. So to know the direction of crystallization, you just connect anorthite with A point. Then it will meet the diapside anorthite eutectic line. So this A will move towards this diapside anorthite eutectic line. So first it will crystallize anorthite because it is an anorthite field. Then it will encounter this diapside anorthite eutectic line. Then along with anorthite it will start to crystallize diapside. Then they will move towards the cotectic point where along with anorthite diapside phosphite will crystallize. So first anorthite, then diapside, then phosphite. So it will be D. Then this is one easy question. As per the bounce reaction series, which are the following represent the correct order of crystallization? First olivine, then pyrogen, then amphibole, then biotite. Then which are the following mechanism facilitate the separation of crystal and liquid when the amount of trapped intercumulus liquid between cumulate minerals is greater than 60% in volume? So when greater than 60% volume means they are able to separate themselves. So if you see in this case, the trapped intercumulus liquid it can be released by filter pressing. By applying pressure, the trapped liquid can separate from the mineral. If it is in this 60%, if that is free or they are interconnected, they are able to separate themselves, they can separate by gravitative settling or other process. But if they are trapped intercumulus liquid, so they are best separate by filter pressing. So if you apply pressure, then the trapped liquid will separate from the solid, by cumulus solid. So it will be filter pressing. Then which are the given trace element ratio can be used to discriminate olivine fractionation from clinopyroxene fractionation? So olivine it has affinity towards nickel and cobalt, and chromium it is concentrated in spineral calibration. So to discriminate this olivine and calibration fractionation, they have to use nickel chromium ratio. When consider the following diagram led to Rayleigh fractionation showing that enrichment and depletion of trace elements like crystallizing magma relative to the concentration of original metals. So you know this element 1, 2, these parts are incompatible, these parts are compatible. You can see this diagram also. These are incompatible element and the lower part are compatible. This is one where fractionation will be equal. So according to this, element 1, 2 are incompatible. This is correct, but element 3 is not. 3 and 4 are compatible. 3 is not compatible, it is in between. You can say it is a transition. The element 1, 2 are compatible with element 3, 4 are incompatible. It is wrong. So element 1, 2 are incompatible. It is incompatible. And element 4 is compatible. It is correct. Then element 3 partition equally into the solid and melt. This is correct, but the element 4 partition preferential to the melt. Because it is a compatible element, it will be preferential into the solid. It will incorrect. So answer will be C. Which one following is not a potassium group of rocks? Which it is comatose, there is a magnesium bearing. And which one of the following is the most appropriate example of high stress metamorphism? Obviously, high stress means we are saying dynamic metamorphism. Which one of the following type of metamorphic reaction can be successfully used in geothermometry? So always remember that exchange reaction it is always occur at a particular temperature and pressure. So that exchange reaction it is always used for geothermometry and also geobarometry. So the answer will be exchange reaction. Because exchange reactions are extremely depend upon the temperature and pressure. The low temperature limit of metamorphism is generally considered to be. So low temperature means you have 152 to 50 degree you can choose. According to other options, in 350 to 50 it is not that much appropriate. 450 it is not appropriate. 50 it will be also not appropriate. So this one will appropriate 150 to 50 degree. Then the cleavage related to microfolding of pre-existing collation. So always that granulation collation is the you can say folding of a pre-existing collation which is formed by two different deformation event. By you can say it is produced by polyphase deformation event. You see this is static cleavage. It is formed by one deformation, then another deformation event, then this static cleavage it got folded, it will produce granulation cleavage. Then in a metamorphic rock, when solution transfer dissolved matrix minerals from high stress area and precipitate in low stress area. So this is the condition where this it is a you can say quatermart structure. So it is a shearing condition where this part is getting extended, this part is getting compressed, this part is getting extended. So the compressional part, it will undergo high pressure condition. So it will dissolute material from this condition, this place, and it will start to deposit in the low pressure area. This is a pressure shadow area. So the extension part. So during metamorphic rock, the solution always transfers to the low pressure region. That is called as a pressure shadow zone. It is found in quatermart structure. Quatermart structure. The answer will be pressure shadow zone. There is also a type of granoplastic texture found in a fine-grained rock in the contact areas. So if you say it is a contact area, then you will find all type of contact metal texture and fine-grained granoplastic. All know that is hornfels. Answer will be hornfels. Then porphyroblasts, which grow over a randomly oriented grains in matrix prior to the development of the collision. So prior to the development of collision means or prior to the development of deformation you can say. So that's why it will be a pre-tectonic porphyroblast. Then also during the progressive regional metabolism of Epirich aluminous pellite, that is staurolite, is produced as a coster. So this is the reaction you can say. So it is produced by reaction of fluoride plus kyanite. It will produce staurolite chloride. So that's why the answer will be D. It is produced on the expense of chloride. Because after you can say chloride zone, Greensish species, we will find granite zone and staurolite zone. Stable mineral assemblies of hornblende plagioclase garnet. So hornblende plagioclase it is the characteristic mineral of you can say amphibolite phases. It is the mafic assemblies. Answer will be amphibolite phases. So also in a low pressure by temperature type of prograde metamorphism, which one of the following is most appropriate? Prograde metamorphism means always low grade will convert to high grade. So the first option is given. Andesite is converted to sillemanite. So if you see the Baravian zone, this chloride, biotite, garnet or almandite you can say. Then staurolite, then kyanite. So it is the case of medium pressure and temperature condition, the Baravian in a regional metamorphic condition. In low pressure we have Buchan zone. In Buchan zone you have biotite, cordierite, andalusite, sillemanite. First, sillemanite converted to kyanite. Sillemanite, if sillemanite converted to kyanite, it will be retrograde. Because sillemanite is high grade, kyanite is low grade. Kyanite converted to sillemanite. So it is for a prograde, but it is in medium pressure temperature condition. It is not in low pressure temperature condition. So Buchan is low pressure by temperature prograde metamorphism. Then sillemanite is converted to andesite, it will be retrograde. Then andesite converted to sillemanite, it will be prograde. So the answer will be A. Then calc-silicate rock formed by metasomatic reaction between marble and granite intrusion. Very common question. This will be scar. So scar always form when any intrusion that occur within a limestone terrain. Then comes presence of characteristic mineral garnet, clinopyrizine, plagioclase, plus minus hornblende. So if you are saying garnet, clinopyrizine, if 100 may be present or absent, it will be granulate phases. Calcite, gypsum and apatite are termed as calcite, gypsum, apatite. You can say they are chemical or biochemical constituent. They are formed by a chemical process or biochemical process. Then also three straight line segments are ideally demarcated when cumulative percentage data sediment having normal grain size distribution is plotted on a log royalty paper. So you will find this particular diagram in Sandbox. This is your diagram where then first your traction population, then saltation population, then suspension population. So the answer will be A. In terms of which one of the following methods of grain size measurement is not preferred for unconcentrated fine sediments like silt and clay? I think comes to sedigraph. So sedigraph always measure sediment size on the basis of Stokes law, on the basis of settling velocity. So it measures particles ranging from 300 to 0.1 micrometer. So it can easily measure this fine sediments. Then goes to pipette analysis. It is also a grain size technique which will determine the grain size between 2 to 63 mm. Okay, you'll find clay and fine type of sediment to easily analyze it. Then these two types, that is your sieving and laser diffraction, both measures a greater range of sediments size. That is, the sieving also measure from 125 mm to 20 micrometer. Laser also measure to 10 mm to 4 mm. So in this case, laser method it is more appropriate than you can say is sieving for final grade. So that's why you can choose sieving technique. It is not preferred for unconcentrated fine size sediments. When both are sieving and laser, they both measure fine size sediments. So laser is more technological thing, so it will be more appropriate analyze the grain size. Then comes to rarely migrated sand ridges in an aeolian environment with unusual heights and in alternative opposite direction. So if you find any dune type or ridge type which is opposite to each other, that is your reversing dune. They flow opposite to each other. The two types of dune where flow is towards each other. That is, one is your reversing dune, another is your, you can say, linear dune or longitudinal dune. So this is a reversing dune where the flow direction is opposite to each other. Then also all other types of dune. You'll find it in the book Sommerfeld, Global Geomorphology, Sommerfeld. So the polycurrent vector data of sediments, which polycurrent data, it is always represented in a rose diagram. The small lenses of sandy mud beds form in a sandy ripple. Three types of ripple form or bedding form during a fluctuating current condition. Sand mud both deposit, that is tracer, wavy and lenticular. So lenticular has more mud percentage, tracer has more sand percentage. So the answer will be lenticular. So this is the condition where lenticular has more mud percentage, where sands look like lenses. Then wavy has 50% sand, 50% mud. Then tracer has more sand percentage than mud. Then based on the depositional structure in allostructural sediments, limestone with mud supported fabric is greater than 10% grain. Mud supported greater than 10% grain will be with a mud supported fabric and it has greater than 10% of grains. It will be wake stone. It will be wake stone. And also quartz arenite, it is sandstone that contains. So quartz arenite, it falls in between this 95% quartz and greater than, sorry, less than 15% matrix. It is in dot classification. So this is a quartz arenite which has more than 95% of you can say quartz and greater than 15% of matrix. So it will be V. Then Hamada are the rocky terrains with vertical cliffs and flat rock surface in. So Hamada is a erosional features that produced by wind in desert region. So answer will be desert. Then the broad expanses of unconfined sediments laden runoff water. So unconfined sediment by unconsolidated sediments with water when they flow downstream, that is called as a debris flow. Then now we will discuss this much, and in the next class we will discuss the rest of the question.